So this is rules of indices question, but this is from a higher paper, okay? It probably will be on a second half of a higher paper. Given that n to the power of minus a half is equals to 27 to the power of a quarter, divide by 3 to the power of x plus 1, find the exact value of x. Now, looking at the question, it could be pretty daunting to just see that all the indices and the equations equal to each other. So where you begin with questions like these is you look at the base. Okay, you start off with the base. The three of the bases, we can see that they will have some form of a connection, and the connection is always the smallest value out of these three, which is over here, or you're looking for what can be a common base for all three of them. So the first question you'll be asking yourself is what is the common base for all three of these values? Okay, so looking at these, we can write common 3. You can't write that as a part of anything other than 3 to the power of 1. 27 can be written as 3 to the power of 3. 9 can be written as 3 to the power of 2. So the link between all three bases is 3. So let's rewrite this question. So the question states 9 to the power of minus a half is equals to 27 to the power of a quarter. Divide by 3 to the power of, I'm going to put that x plus 1 in bracket. So let's rewrite that, linking the base 3 for all of them. So what we can do here is 9 can be written as 3 squared. So we can write that as 3 squared, and then to the power of a half. And then equals to 27 can be written as 3 cubed. Okay, and then to the power of a quarter. And division, well, we can really leave it like that, but you can put it as a denominator of a fraction as well, but we'll leave it like this for now. Then what we can do is, so what do we do when we have something brackets and a power inside, a power raised to another power, is you multiply these two. So the operation between these two brackets means times. Same idea here, brackets mean times. So you multiply those two values. So what we're going to do here is we're going to rewrite that as 3 to the power of 2 times minus a half is equals to 3 to the power of 3 times a quarter divided by 3 to the power of x plus 1. Now 2 times minus a half is, if you remember your fractions, that's actually written like that, 2 over 1 times minus a half, which is minus 2 over 2, that's minus 1. So that's going to be 3 to the power of minus 1. And then this over here is 3 over 1 times a quarter, that's 3 over 4. So that's to the power of 3 quarters. Okay. Now division, when you have the same base, means the powers must be subtracted. That's why we kept it in bracket there, because it's a whole expression. Always better to keep things in bracket when it's a full expression. So now what we can see from here is the base are the same and they're equal to each other. This is equals to this, which means the powers must match. So the powers here must equal to each other. Okay, that power is the same as that power. So what we're going to do is we're going to make them equal to each other. So minus 1 must then therefore equal 3/4 bracket x plus 1. Expand the bracket and solve for x. So what we're going to have here is minus 1 is equals to 3/4 minus x minus 1. Okay, make sure you're extra careful when you're expanding that. Our subject here is negative. Always take the subject away and make sure that your subject is positive before you work on anything else. We want to find x, we need x positive. So taking x to the other side, x is positive, 3/4. Take the minus 1 to the other side. Okay, what you've done here technically is you've added an x on both sides. And then what you need to do next is you add a 1 on both sides to get rid of that. Okay, so that's gone there and that's gone there. And so what you are left with is 3/4 minus 1 plus 1. That cancels out. So x is equals to 3/4. I'll just rewrite that. X is equals to 3/4. Okay, this is considered like, you know, a higher level of rules of indices question. So you can see the full question here. So it's a bit more advanced than, you know, basic rules of indices questions. Thank you for watching.